We're in part 3 of the autonomic nervous system, and we're focusing right now on the parasympathetic in part 3 on page 528 here. And we're taking a quick look at the cranial outflow. And in this case, the cranial outflow begins with cranial nerve 3, and we have something referred to as the ciliary ganglion. The ciliary ganglion is not somewhere between the brain and the eye. It's actually right in the connective tissue of the sclera on the side of your eye. It's right there. Okay, we did have a wonderful dissection on a Friday night dissection class in the cadaver room in this past spring semester before the pandemic hit us hard. And we had one of our favorite students actually go in with a microscope, little eyepiece, and go in and locate the ciliary ganglion. Okay, so fearfully and wonderfully done, found in there. So it's actually, that's where you look for it. Okay, and the purpose of this, of course, is to create a constriction of the pupil, among other things. There's some other things that are going on. We have anything to do with the ciliary body, ciliary muscles, ciliary process, and to do with the iris, of course. So we have that going on. Cranial nerve number 7 has a couple of outflows. One outflow from the facial nerve here, number 7, is to go to the pterygoid ganglion, which is actually in here. This ganglion, this synapse right here, is actually in the septum, or behind the septum, deep in here. You have to actually, in medical school, they give you a partially metabolized half head that's been in digestive enzymes, and they use their scalpel to cut away and find the location. And then from there, it will go to some of the glands of this area. You'll get a runny nose. It will also come up here to the, you can't tell that it's going to the tears right here, the lacrimal gland. So that's part of what's going on with facial nerve. The other part of facial nerve is coming down here, and it's going to the sublingual and the submandibular, which is in the neck region. Okay, and then the next thing that we have is cranial nerve number 9 coming to the otic ganglion, and ultimately, again, that's in here. And the parotid gland is a third salivary gland. The location of the parotid is right here in front of the ear. Okay, there's another thing that's going on here with cranial nerve number 9, but they're not telling us, and it actually has to do with the carotid artery bifurcating into the internal and external, and there's a little something called the carotid body that looks at blood pressure and blood gases. So they failed to mention that, but we'll pick it up. No worries whatsoever. Okay, then we also have now the vagus. The vagus comes over here, and instead of having the effect you might expect it to have on the heart, which is to make the heart do something, it actually slows the heart down. Okay, so the heart in and of itself would like to go around 110 beats per minute, but a normal person's heart rate is more like 70, and an athlete is usually quite a bit less than 70. An aerobic athlete, like a marathon runner, might have a heartbeat that's even below 40 as a normal heartbeat. Okay, it also regulates lung activity, although it does not regulate the diaphragm. The diaphragm, as we learned earlier, is regulated by C3, 4, and 5, keep the diaphragm alive, and that's the phrenic nerve. So this is actually having to do with the regulation of breathing in terms of the smoothness of the cycle of breathing. Okay, so this is, you can see it's coming from the medulla, and it has some interaction with the pons And so the idea here is that we're going to be having programs from both for the heart and the lungs. There's a cardio-acceleratory software here in our brainstem, as well as a breathing software in which we have smooth sine wave types of activity unless there is some sort of injury. We also have outflow to the liver. The liver produces most of the growth factors of our human body at night, which then go out to the various locations of the body locally and reside and function throughout our day. We have the digestion of food in the stomach. We have the outflow in the pancreas of enzymes for digestion in the small intestine. We have the activity in the small intestine, muscular activity, as well as the muscular activity of the large intestine. Here it ends. I'm sort of pointing right here to the splenic flexure. This is the end right here of vagus innervation of the large intestine. And then beyond that, we have to rely on S2 to S3 to come in with what's called the pelvic splanchnic nerve. The pelvic splanchnic nerve is going to come over to here, and then down, down, down here in the descending colon, sigmoid colon, rectum. Okay? And also the pelvic splanchnic nerve is going to serve the uterus. It's going to, I'm sorry, this is a bladder, this is a uterus. It's going to take care of the uterus. It's going to take care of any subtle activities. Here, at the time of ovulation, there is a type of activity that goes on with the fimbri of the fallopian tube, in which the fallopian tube and fimbri get to catch the ovulating ova from the ovary. And so there's also all sorts of how shall I say, muscular activities that are a part of the normal function of the menstrual cycle as it relates to the uterine musculature. Okay, and then also with the male reproductive organ, the penis, there's going to be the type of thing that you might expect, which is the flow of blood into little chambers, connective tissue chambers, and allows for erection of the penis. There's other activities related to that are all a function of parasympathetic tone. Okay. With adequate sleep, all of this works much better because the biosynthetic pathways are full on at night in the 8 hours of sleep. Particularly in the second 4 hours of sleep, the liver is fully engaged to make the small little growth factors that need to be distributed to all of the local tissues of the body. So, and when I say second 4 hours, that means that you really need to go 8 hours to get all of that, and then everybody is quite happy because they've had their situation addressed. The one place where it would be good, we'll see this a couple different times in the book. In this chapter, we'll see it because it's here, and because it's also in the reproductive chapter. So we have something called the sexual cycle, and in most books, unfortunately, unless it's a psychology book, they only look at the first two of these arrows here, and only that I've noticed in psychology books do they pay much attention to the third arrow. So, but there is in fact 1, 2, 3 parts of the sexual cycle. The first part is parasympathetic. It's called arousal. This is a period in which various tissues can become, how shall I say, swollen with blood. They can become engorged and erect. That could include everything from the lips of the face to the nipples to the sexual organs. So there's a number of features that are in that manner. And so there is a parasympathetic preparation, and then there is a what's called climax. So there is an epinephrine explosion, so to speak, and we could call it a climax or an orgasm. And the idea here is that there's going to be involuntary contraction of a number of muscles. Where does all of this happen? I've already mentioned to you that when it comes to sympathetic nervous system, it is a full body experience. And then there is going to be a recovery period. And in this period, I refer to this as the oxytocin or cuddle portion of the sexual cycle. Okay, so, as I noted that there's medical textbooks that more or less end right here. You know, they've already lit the cigarette, put the hat on, and they're heading out the door. But in fact, there is in fact this third stage, which is extraordinarily significant, and probably is what bonds long-term relationships. Okay, so there's that.